All right, I got a little chilly today, so I had to put more on. Let's try to do this problem. It's a really funky one, so good luck, and let's do some math. Okay, let's see if we can do this one. 2009 B, question number 1. It's funky, and it's important to do problems you haven't seen before, because they'll get you with them, because they're brilliant people who don't quite understand how somebody like me or you think. So, let's see. At a certain height, a tree trunk has a circular cross-section. Okay, the radius, and here is a formula to find the radius, or a function that'll find the radius of the cross-section, grows at a rate modeled by this. So the rate of change of the radius in terms of time is this function, centimeters per year. For 0 to 3, where time is measured in years. At time equals 0, the radius is 6, okay? The area of the cross-section at time t is the function a of t. So that's the area, the radius r of t, the rate of change of the radius is dr dt. Okay, I think we got it. Write an expression involving an integral for the radius. Okay. So we want the radius. And this is a no calculator, so we need to figure this thing out. Here's dr dt, the rate of change in terms of time. That's a of t. So this is the same thing as r prime of t, right? Because the variable is t, and it's the derivative of radius, so it's the same thing. So this is what I'm thinking. The radius is the initial radius at time equals 0, so it's 6, plus an integral from 0 to t of r prime. So when you integrate the rate, you get the total amount of x dx. I think that is an integral expression that we can do. Okay, so this is a graphing calculator problem, so we can do that pretty easily. Oh no, it's 6 plus, right? 6 plus the integral from 0 to in this case, we want to find from 0 to 3. We'll go y1 dx. And then in y1, we'll put it in. Usually I do the problems beforehand and I already have them in, but this time it was hard, so I wanted to actually struggle through it so you can see what extra things I have to think about. If I'm too polished, I don't think it's as authentic. X squared. I think that's it, right? Oh no, I need another parenthesis. There. I think that's it. 160, okay. And that should give it to us. 6.6108. So r of 3 is 6 plus the integral from 0 to 3 of r prime of x dx, which is 6.6108. Okay? And to find the radius, so it's centimeters. right? That's the radius at time equals 3 at the end of the third year. Okay, so for B, find the rate at which the cross-sectional area, so d80t, increases in terms of time, indicate units of measure. So we're looking for, well, we can find an A of t, right? And then take the derivative. So this is hard, it's all notation. But we can find the area, right? All we need to know is a radius, and you go pi times radius squared, okay? But the radius changes as time changes, so we've got this, A of t. Okay, so there's the area. That's not too bad. And then we want to find the rate of change of the area. So we want A prime of t. That's 2 pi times dr dt, times r of t times the rate of change of r of t, so r prime of t, okay? So we just took the derivative of this outside function, 2 times this to the 1, and then you multiply by the derivative of what's inside. So A prime of 3 is 2 pi times r of 3. Do we know that? Yeah, it's that number. Times r prime of 3. Do we know that? We can just plug 3 into this, so that shouldn't be hard. Let's do that. R prime of 3 is, and I think this is the r prime, right? So we can just go to the table and plug in 3 and get 0.213257. 213257. Okay. I think also, I might be right. I think I can go y1 of 3 and get that number, okay? So let's just do this. 2 times pi times this number, right? Times the last answer. $8.8581. 8.8581. And this is, find the rate of change of the cross-sectional area. So it's square centimeters per this is the rate of change of the area, rate of change per year. Okay, and C, looks like I might make it. Evaluate this integral. So we're going to integrate A prime of t dt. Okay. So when you integrate the rate, you get the total. So if we integrate the rate at which the area is changing, we're going to get the total area. However, it won't be the total area. It'll be the displacement of the area, right? The total area, remember, since the radius started at time equals 0, the radius is 6, the initial area was 36, right? Am I lying? The radius is 6. At time equals 0, the radius, I don't think I'm lying. But this does not account for that, right, on this problem. So this just will give us the displacement from time equals 0 to time equals 3. So let's see. If you integrate a prime, you get a. So this is a of 3 minus a of 0. And that's, do we know? A of 3 minus a of 0. We can figure that out, right? Because we do have an a function. So a of 3 is pi r of 3 squared. And a of 0 is pi r of 0 squared. R of 3 we know to be. Okay, so a of 3 I'll do right there. It's pi times r of 3 squared. And r of 3 we found right here. So it's pi times that number r 3 squared. Okay? 6.6108. But make sure you use all the decimals. You will get it wrong if you round this. Don't round. Okay? See all this white out? You know why I had to do that? Because I couldn't find that number really easily. And I rounded, and then I got the wrong answer. And then I had to erase. Don't round anything until your final answer. And that is 137.29799. 137.29799. Now, a of 0, that's easy, is pi times r of 0, which we know to be 6. Okay? So we can do this right here and find that answer. It's this last number, a of 3 minus 36 pi. So the last answer, minus 36 pi. And that's 24.2007. 24.2007. So this is the area of the cross-section time equals 3, area of the cross-section time equals 0. And we subtract that, we get the area of the cross-section, let's see. This is like the displacement in the area of the cross-section. Because when you integrate a rate, you get the total amount, right? The total displacement, if we know the initial amount. And the initial amount is this 36. So this is the displacement in the area of the cross-section. The displacement in the area of the cross-section from time equals 0 to time equals 3. Oh, we need units. And it's just an area. When you integrate a rate, you lose that per year. And these are just centimeters squared. Is 24.2007 centimeters squared. Okay, so I described what it is, I said the time interval, and I have the correct units, and that's what you need when you give an answer.